Welcome to the internship program. I am Shubham Gupta from NextGen AI Frameworks Private Limited. I have more than 14 years of work experience in the fields of artificial intelligence, software development, and robotics. In this session, we will be talking about basics of transfer learning. Okay, so what happens is, as you know, for training we will require lot of data and time. So machine learning models typically require substantial data and time for training. This requirement can be barrier in cases where data is scarce or training resources are limited. So if you are training for example some specific part like training, let's take a simple example of bottles, for example bottles. So you already have pre-trained models in the market, as you know. So if you want to train your own model from scratch, you have to collect at least 1,000 images of different type of bottles from different angles and then train the machine learning model. So you understand this, there are barrier in cases where data is scarce. Sometimes some detections or products and services are not available in the market and their images are not available, and training resources are also limited. So for example, if you don't have GPU on your computer, powerful GPU, then it will take months and years to train machine learning models. So what transfer learning is? So transfer learning offers a powerful solution by allowing us to leverage knowledge from a model trained on a similar task and apply it to a new but related problem. So this technique can save time, resources, and sometimes lead to more accurate models, especially in applications where high quality labeled data is hard to come by. So we will be using a pre-trained model and then adding some features on top of it. This is what transfer learning concept is. So transfer learning is a machine learning approach in which a model developed for a particular task is reused as the starting point for a model on a second task. This method is particularly useful in deep learning, where models are often trained on vast datasets and require significant computational power. So you understand this, the more the data you have, more compute power you will require to train a machine learning model, and it will take hours, months or years to train some complex models. So what you can do is use some pre-trained model as the base and then build your model on top of it. So why use transfer learning? Faster training. Since the pre-trained model has already learned useful features, training on the new task requires less time, less data required. With a pre-trained model, you need a smaller data set to achieve good performance. Improved accuracy. Transfer learning can help achieve better accuracy, especially when labeled data for the target task is limited. And efficient resource utilization. Transfer learning maximize the use of pre-trained models, reducing the need for extensive computational resources. Maximize the use of pre-trained models, reducing the need for extensive computational resources. With less resources, you can train your machine learning model. So how does transfer learning work? So transfer learning typically involves the following steps. Choose a pre-trained model. Select a model that has been trained on a large relevant dataset. Common choices include models trained on ImageNet for image recognition task, or models trained on a large text corpora for natural language processing. Then comes the customize the model part. Freeze the initial layers of the model to retain learned features. So already the features available in the model will be used, and fine tune the later layers on the large or target data set. So bring the new data set, new images, and then train your model on it. So as I told you, base, we already have some base features that were previously trained, or the model was previously trained, and then we have new data set that will be used to train the model or add the features to the existing model. This allows the model to adapt the specific nuances of the new task. Train on the new task with the model structure in place. Retain the model using data from the target task. You may need to experiment with hyperparameters. If you remember what hyperparameters is, they are settings for the model. So you have to change some hyperparameters, especially the learning rate, to achieve the best result. So we have the base model, we have the new data set, we will use it to train the machine learning model or fine tune the machine learning model we trained previously. So let's see where it is being used. So applications of transfer learning are computer vision. Tasks like object detection, image segmentation, face recognition benefit significantly from transfer learning. Models trained on ImageNet can be repurposed for these applications with minimal data. Natural language processing. Transfer learning is foundational in natural language processing, where models like BERT and GPT are trained on vast amount of text data and fine-tuned for specific applications like sentiment analysis, question answering, summarization. So you already know about ChatGPT. So what happens is, there is some base model, then we can customize the base model based on our requirement. So for summarization, question answering, for all those specific tasks, it can be used. If you look for chat gpt also and look for these model, great for most tasks. Collaborate on writing and code, uses advanced reasoning, faster at reasoning, faster for everyday task, legacy model. So you can see each model has some advantages. So this is what it is telling us. Speech recognition. Transfer learning enables the adaptation of speech models for different languages or accent, making it possible to train high quality models with less data. So you understand this. I am speaking English. Chinese are also speaking English. In USA they are speaking English. In UK they are speaking English, but they have different accent, different tonal quality, and all those things. So we can take some base model, and based on that we can train a new model with less data, and we can create high quality models. So we can have a base model and create or develop a model on top of it. This is what transfer learning is. In medical imaging, transfer learning has proven valuable in fields like radiology, pathology, where annotated data is limited and labeled by experts. So if you have already available data, you can use it, or previous model you can use it. Example, transfer learning with image classification. So let's see in image classification how this transfer learning can help. Suppose you need to classify images of specific dog breeds, but you only have a limited number of images per breed. Okay, so you need to classify images of specific dog breeds, but you have only limited number of images per breed. So what you can use transfer learning. Select a pre-trained model, choose a CNN like ResNet or VGG that has been trained on ImageNet. Modify the model, remove the last fully connected layer and replace it with the new one with the number of classes in your dog breed dataset. Freeze layer, freeze the early layers to retain the general image feature like shapes, edges, etc. Fine tune the model, train the model with a small learning rate on your dog breed images, allowing the models to specialize in the specific classification task. So you have in the ImageNet and other already available Neural networks, you already have neural networks available on the internet, and they were trained on millions of images. So you understand this, you cannot collect millions of images on your computer and start from scratch. So what you can do is get the ResNet or VGG that are available on the internet. So if I search for ResNet, reach it can reach up to depth of 152 layers. First trained and tested on ImageNet and won the ImageNet large scale visual recognition challenge. And if you look for ImageNet, is a large visual database designed for use in visual object detection software research. More than 14 million images have been hand annotated by the project to indicate what objects are pictured, and in at least 1 million of the images bounding box are also provided. So you can see the amount of data they have used to train the ImageNet contains this. So object classes, what it means, different objects available in the image. So if you have image like car image for example, so in this let's see some, okay, so in this image you can see we have green trees available. So this will be one class. We have this car, this will be a class. We have this fort, this will be a class. So what class means here is 1000 object classes, means 1000 types of data is available. Okay, so this is what classes means here. So you can see they are it is already being used in the market. So types of transfer learning, inductive transfer learning. So these are the three types. Inductive transfer learning, here the source and the target tasks are different, but the source and target domains are same. For instance, training a model on large text corpus and fine-tuning it on sentiment analysis. Transductive transfer learning, this involves using knowledge from a source domain for a similar task in a target domain. For example, training a model on English text and applying it to similar tasks in Spanish text. So transductive transfer learning. Unsupervised transfer learning techniques are applied where the task is unsupervised, such as clustering or dimensionality reduction. I already told you about clustering and dimensionality reduction in previous sessions. So you can check out the article and videos on YouTube. Clustering and dimensionality reduction. There also unsupervised transfer learning can help save space and resources. Okay, so let's see the benefits and limitations. Benefits are: reduces the need for large data sets, reduces training time and computational cost, improves performance on limited data. What are the limitations? May not work well if the source and target domains are too different, requires careful tuning to avoid overfitting. Pre-trained models may include biases present in the original training data. So these are the limitations. Look for the benefits. It will improve the performance, save the time. So popular frameworks for transfer learning: in TensorFlow and Keras you can use the approach to do the transfer learning. Provide a range of pre-trained model like MobileNet, ResNet or VGG for easy adaptation. Then you have PyTorch, offers models in TorchVision.models including ResNet, Inception, EfficientNet, which can be used directly for transfer learning. So we have in PyTorch also available. Hugging Face Transformers, a library that allows you to use pre-trained natural language processing models like BERT, GPT and Roberta for transfer learning tasks. So you have these popular frameworks also available for transfer learning. So overall, what is this. So transfer learning is a powerful method that accelerates the development of machine learning models, especially in cases where data is limited or computational resources are constrained. By leveraging pre-trained models, we can reduce the need for large dataset, speed up training times, achieve high performance with less data. With continued advancement in pre-trained models and frameworks, transfer learning is becoming this important tool in the machine learning toolkit, enabling more efficient and effective model training across various fields. In next session, I will create a project for transfer learning. See you in next video. Have a nice day.